Okay, so we're gonna finish going over if else and make sure it makes sense. And I want to start with a basic structure, and we don't need the hello world, but our basic template. And what we're gonna do is we are going to do a book club example where you get different points for reading different amount of books. So we could go ahead and put our comments at the top. And we can see book club points using conditionals. And so basically what we're going to do is we are going to find out how many points they earn based on how many books they read. So the first thing we need to do is we could say pseudocode here. We need to take in how many books they've read. So input books. And then we'll determine how many points they get based on how many books they read. So if they haven't read any books, so if the books is 0, then we'll say print 0 points. And then if it's not 0, the other option is, so instead of doing separate ifs, we're going to do else if. So else if it's not 0, then what else could it be? Well, it could be 1. They read 1 book. And so if books is 1, then we'll print 5 points. And what if it's not 0 or 1? Well, we'll do another else if books is 2. So if you read 2 books, then you'll get 15 points. Okay. And what if you read 3 books? Let's see, if books is 3, print 30 points. And then if you've read more, if you've read at least 40 books, we'll say, so if you want to do 40 books, you can say else print 60 points. You get 60 points if you read 4 or more books. Okay. Does that make sense to everybody so far? Okay. So we're going to use this logic to fill out our code over here. Oh. So first we need to input a number. So we need to have a variable to store that into. And if you're talking about the number of books, then it wouldn't be a decimal number for the number of books because, you know, well, we're not going to count it if you read a half of a book. You have to read the full book to get credit. So we're going to see int books. That's how many books. You could call it number of books or number, but we're going to call it books because that's how many books you read. And then we're going to ask the user, how many books did you read this month? Okay. And then we need to take in that data and we're going to save it in our variable called books. Okay. So we ask them how many books they read. We take it and we save it in books. And then we start with our first condition, if that books variable. No, we can't say is. So we say equal 0. And then we see out you earned 0 points because you didn't read anything. So you didn't earn any points. Okay. And then again, instead of doing separate ifs, even though you can't be 0 and 1 at the same time, if they're connected, like you couldn't have read them a different number of books. You're just going to input one number. Then we're going to connect them with else if instead of doing if, just because they're connected, it makes sense. Even though it can't match more than one, it makes sense to do it that way. And so we're going to do else if books equal 1. That means you read 1 book. You can't put a space between the equal either. You need to leave them together, but you can put a space before and after the 2 double equals. Okay, so we're going to say see out how many points did you earn? So that's this part here. We earned 5 points. Oops. So we'll say you earned 5 points. Okay, then what other option do we have? The next option is you read 2 books. The books equal 2. And we'll say you earned 15 points. Okay. And then the other option is you read 3. The books equals 3. And that would be 30 points. Is everybody okay so far? 30 points. Okay. And then the last option is that you read, if you didn't do 0, 1, 2, or 3, then you had to read 4 or more. So we'll put else, and we'll say you earned 60 points. So we'll say the max is 60 points. So you earned 60 points. Okay. So it's only one of those options. And so if you run it, hopefully, if you enter a number of books, so if you say 0, it says you earned 0 points. You've read 4, you earned 60, 3, 30. Just try all your different options and make sure you're getting the number of points that you had over here in your pseudocode. So it looks like it makes sense. It's working correctly. Okay. Is everybody following that? Does that make sense to everybody? So we do have an easier way to do this. When we get to the switch statement, we'll talk about how this could be simplified with a switch. But this is fine the way we have it. It works like this. The only thing is if you run it and you enter a negative number, it's going to tell you earned 60 points. And the reason is because you don't have an option for an invalid here. So if it's not 0, 1, 2, or 3, then it automatically goes and you earn 60. And so if you put a negative number by accident, it probably shouldn't give you 60 points. It works for everything else because if you read 50 books, then you're going to get 60 points because anything 4 or more would be 60, but it doesn't really count for negative numbers. Like if you put negative number in there, then it doesn't register as that, and it just gives you this else because it's the only option it has. It doesn't have an option for the negative numbers. So there's a couple ways you can change that. If you're worried about negative numbers, you can think about it, well, I can handle that at the beginning. So my first thing can handle all negative numbers. So I could start with an if that says, if books is less than 0, then invalid, right? You could do that at the very top. And then everything else could be an else if after that. So that's one way to do it. You can also make this else at the end an else if and make it if you read books are greater than or equal to 4, then do that. So it would look like this. So if we wanted to modify this, we can make this an else if, and we can say that if the books is greater than or equal to 4, meaning that you read 4 or more, you can't switch around the equals and the greater than sign. No, that doesn't work. So you do have to put the greater than sign first, then the equals. So meaning if you read 4 or more, then it'll print that. And if you just do it like this and you don't add anything else, then it won't do anything if it's invalid, which is fine if that's how you want to handle it. So if you look now that it's not an else, it doesn't have to happen. So if you read more than 4 or more books, then you earn the 60 points. But if I do an invalid number again, then it doesn't do anything, which is fine. I mean, maybe you don't want to print or do anything if it's invalid. That's an option. It just depends on what you're trying to do. So you can, at this point, leave it, or you can add an else on there that's invalid, because now we've handled everything that's 4 or more. So the only other option would be a negative number at this point. So you can either put the negative number at the top of the list or the negative number at the bottom if you wanted it to print invalid. And so there's a couple options again. You could go to the top and you could say if books is less than 0, then C out, invalid. And then we change this to an else if because we want them to be connected. Okay. So if you have a negative number, then it should match invalid. So you could put that first in your list and just handle invalid right away. Or you could put invalid last in your list. So that's one way to do it. You could put it at the top. Or if you wanted, again, you can move this to the bottom and whatever way makes the most sense to you. I can leave my if with the 0 books at the top. And at the bottom, I can just go with else because now my only option is the invalid because I've already handled this one because this one is an else if. Then the only option should be a negative number. Just have to make sure that you're not counting books that are too high. Like if someone is being crazy and say they read 1,000 books in a month, then that probably is invalid too. I don't know what you want to put as an upper bound. But at this point, maybe we don't have an upper bound, but maybe at some point you'd want an upper bound saying that that's just not possible to do. And so if that was true, then you'd want to put a range on this. So like right now, if I do this just to show you it works, then if I put a negative number, that's going to stop it. But if I put if I put a reasonable amount, then I should get the points. But if I put an unreasonable amount, like 5,000, like that's not possible, then it's going to say 60 points. But maybe I meant to put a smaller number, like maybe I meant to put 3, but I put some zeros out and I put 300 instead of 3. And so that's not really what I was supposed to put. I was supposed to put 3. And so really, maybe you want to put an upper bounds on this. And what I mean by that is right now, this condition is saying that if it's greater than equal to 4, but nothing is stopping it from being too large. And so if you want to stop it from being too large, then you could do something like this. You could say, and books is less than equal to whatever a reasonable number is. And so how many you think you could read in a month? Maybe 35 or, that's still a lot, but okay. So whatever a reasonable amount is, put a reasonable amount so we're not getting hundreds here because that would probably be unreasonable. Okay, so then if I enter something like 300 by mistake, put 30, let's put 300, then it'll say invalid. And so what I did is I created a range here. So range is used with and. That means that it has to be between this and this. It's a way of saying between. And when you're doing invalid, if you are going to do it as a condition, not as an else at the very end, if you're going to put, what is the criteria for invalid, then you have to go with or, like less than this or greater than this. You can also do that. And so that's an option. So you can do this a number of different ways. Like at the top, if you wanted to handle invalid again, if you wanted to move it to the very top as the first thing, you can say that if books is less than 0, or if books is greater than 35. You can do that criteria. If you're doing invalid, it's an or. If you're doing between, it's an and. And so it just takes practice, and it also depends on how you're thinking about it because there's so many different ways to mix match this. Typically, you either start with the smallest or the largest. We don't start like in the middle. Like, I wouldn't start with if you read 3 books because, it just makes sense to start at the top or the bottom. But you can start at the top or the bottom and work your way down. Whether you handle invalid at the top or the bottom is up to you. Just make sure that when you're going through your decisions that you can't match one before hitting the other and accidentally, like, when I left off the how many as possible to read, then it's going to match that one before it gets to invalid. Like if I put 5,000 books and it didn't have the upper range less than 35, then it's going to hit that before it ever gets to the else to say invalid. So you have to be careful that you handle that because that's probably not a reasonable number of books that you can read. Nobody can read 5,000 books in a month, so we shouldn't have that on there as a valid criteria. So is everybody with me on this? So you can mix match this any way you want. You can play around with it. These are, once you have it working, go ahead and paste it over here so that you have it as an example. And I know we changed this a bit. This is now. Yeah. No, Yes, so great question. It doesn't matter really if you put 2 or you put 1 ampersand there, it actually works either way. In some scenarios, it matters, but in this one, it doesn't. So, whenever you put, so and, do you understand and, the difference between and or in general? Like and means you have to have both, so it means the between, and or means usually two opposites. So it doesn't, but if you're saying like, do I put 1 ampersand or 2 ampersands in this class, we're not going to do anything that matters, whether you put 1 or 2. But what it is when you do 2, it's called short circuiting. And so what happens is it takes less time. So like when you're running the program, if it finds out that this first criteria for an and is false, then it won't even bother to look at the second criteria because they both have to be true. So if it finds out that that number of books is not greater than or equal to 4, then it won't bother to evaluate the second side because it's a waste of time because they both have to be true for it to be true. So it's like a time saver, basically. It's like when you have the double ampersand, it doesn't evaluate the second side if it knows that it's going to be false. So if it knows that it's going to be false in an and, it won't do it. And an or, if it knows it's going to be true, like if the first one's true, it doesn't bother to look at the second side because there's no point. So like it's like if I asked you to bring a pencil or a pen to take the test in class, and I say, did you bring a pencil? And you say yes. Would I bother to ask you if you brought a pen? Probably not, because it doesn't matter, right? Like, I mean, if you did, that's great, but it doesn't matter because you're prepared, right? So it doesn't bother to ask the second side. Now, if an and, like if I ask you, if I say you have to do this, and I ask you the first one, you didn't do it, then I might not bother to ask if you did the second because you didn't do what you were supposed to do. So I would say, okay, this is the punishment for not doing this, or this is what we're going to do. But if you do 1 ampersand, then it does bother to check the second side. And in some scenarios, it's important to check both sides, even if the first one's false, because you might still want to do something in the case. But it's hard to explain that right now. But for this class, like it doesn't matter. It's not going to make any difference. And you won't see the time, like when you click run, whether it's 1 or 2 ampersand, it's really not going to matter. But we just use 2 by default because it saves time. Yeah, but great question. But if you accidentally just put 1, it still works. And it doesn't make much difference. So yeah, the question was, do we put 1 ampersand here or 2? And really, it doesn't matter. I mean, it's the time saver is not gonna, you're not gonna notice. Okay. And then I changed this to an else. I was just changing my pseudocode to match. So we're gonna print invalid. And then I have this saved. And you should probably save this so you have this for later. So give it a name that you'll remember. So maybe like book points or something like that. This is for you to have so that you have it in case it's a good example for you to look at. If you're like, I want to know how, if I match this number and this number and this number, what that looks like. And so this code will help you with that, hopefully. And feel free to take this and change this if you need more practice. If you still feel like you're struggling, try to take it and change it a little bit. So try to take it and put invalid at the top. And how do you handle making this an or at the top? So try playing around with that and see if that helps you understand the difference between all that. Is everybody good on that? So use this as a reference to play around with and practice with. Okay. I have this next example for you on Canvas, so you can pull it off there if you haven't already. And I'm just going to paste mine in. It's a long example and I didn't want you to have to type it. So it's posted on Canvas. So you can pull it off there and look at it. You can look at mine for now, but you can pull it off later and use it as a reference, and you can play around with it if you want to and change the code to see what's happening. But what this is basically using conditionals to decide what menu is going to be printed. So if you have, if you're gluten-free, or if you're vegetarian, or if you're vegan, you will get a different menu than if you're not any of those things. And so depending on which of those you say yes to, will depend on which menu you get. Okay, so if you don't have any of those things, then you'll get everything on the menu. But if you have like gluten-free, you'll only get the places to eat that are gluten-free. And so what we do is we have these variables at the top. And the purpose of the variable is to keep track of if you're vegetarian, if you're vegan, or if you're gluten-free. So when we first start off, we just put them all at false. But if you answer the question that you are one of those things, then it will set them as true. And so really what the point is we go through and we ask them if anyone in the party is vegetarian. And if you say yes, then it's going to set the vegetarian variable at true. Okay, so it knows you're vegetarian. It's keeping track. So if you have someone that's vegetarian, then we're going to get a different menu of places to eat at. So why did we do capital Y and lowercase y. So I think this is a good example of or, because when you type Y, it makes a difference whether it's capital or lowercase, because your computer, when it's comparing the Y, it has to know which one it is. And so a capital Y and a lowercase y compared together are not the same thing. And so you have to do both of them, unfortunately. Now, this is a char, so it wouldn't work if you actually type the word yes. It have to be just Y, because it's just comparing a char. And that's why it has single quotes around it. If it was a string, it would have double quotes. And you could use a string. You would just have to put double quotes and you would have to write out the word yes. Now, the word yes makes it a little more complicated, because then you have to compare if it's all capital yes, if it's all lowercase yes, or if it's yes with a capital Y and lowercase e s. And so just going with Y makes less choices for you to make a mistake or for someone to enter the wrong thing. And so just going with Y is a little easier, but it gives you both options. It's comparing your input to see, is it a lowercase y or is it a capital Y? So it gives you both options. And then it sets this, and then it goes through to ask, is anyone vegan? If that's true, it sets the vegan variable to true. Is anyone gluten-free? If so, it sets the gluten-free. Now, what if you're all three of those things? What if all of them are true? Then you're going to have less options of places to eat. Okay. So then it prints off a menu of here's your restaurant choices. And so here, the if, this is a good example of not, because that exclamation point means not. And so if you're not vegetarian, you're not vegan, and you're not gluten-free, if you're not all three of those, then you can eat at the burger place. But if you're one of those, then we're not eating at the burger place because it doesn't have any options. All right, does that make sense so far? Now, if you're not vegan and you're not gluten-free, then we can eat at the Italian restaurant. If you're not vegan, you can eat at Main Street Pizza. And then everybody can eat at these two, the Corner Cafe and the Chef's Kitchen. So regardless of which of those you pick, you'll get the last two because there's no condition there. But if you're, if you look at it, of course, if you're vegan, see how it has these three options say if you're not vegan. So meaning if you're vegan, you won't get to eat any of these three. Okay. But if you're just gluten-free, then you'll be able to eat at this like Main Street Pizza. Does that make sense, everybody? Okay, so let's see what it looks like. So it's going to ask us a series of questions. Is anyone vegetarian? We'll say no. Is anyone vegan? No. Is anyone gluten-free? No. So we get all the options because we're not any of those things, okay? Well, then let's try it again. We'll say no, we're not vegetarian, not vegan, but we're gluten-free. Okay, so you get less options when you're gluten-free because remember the gluten-free one, you got this added, you always get the last two, but you got the added pizza one because they have gluten-free options, because so it just says, just if you're not vegan, then you can't eat there, but you can eat there if you're gluten-free. But if you're gluten-free, you can't eat at these two. So let's try being vegetarian, because vegetarian, you can eat at this one as well, the Italian place. So let's try that one. So what if you're vegetarian, but you're not vegan or gluten-free? Then you get the Italian place. Okay, what happens if you're vegetarian, vegan, and gluten-free? Vegetarian, vegan, not gluten-free. Do y'all see the idea? So you always want to test it a number of different ways. Make sure your decisions are working. I like this example because it gives you the nots, which we don't use that often, and how it could be useful to kind of test those variables. So you don't have to say the variable does not equal true. Like this, when you say it, like let's take this one, for example. This one, you could just say not vegan, which usually makes sense to everybody. You don't have to say vegan does not equal true. You can say that, but you don't have to say it. It's a little bit longer. So usually we just say not vegan, which means like that variable is not true, which means it's false, right? Does everybody understand the wording of that without doing the not equal to true? You can do that if you want to, if that makes more sense. Okay, so you have this example on Canvas, so you can take a look at that. I have a couple other examples for you. This one is about newtons. And so this one, we have some input. We're taking in what's the mass of an object, and we're going to multiply that mass times 9.81. Then we're going to tell you what the weight is in newtons, and then we're going to say if that object is heavy, light, or just right. And so if that object is between 10 and 1,000, then it's just right. So the and means between. If it's greater than 1,000, we're going to say it's too heavy. And then the only option left is it's too light. So too light would mean that it has to be less than 10. So this would match everything less than 10. Okay, so if I run it and we put in 89, for example, it's going to tell us how much that is in newtons, and that object is just right. So if I do something smaller, that one's just right. If I do a negative, that's too light. And then do something really heavy, that's too heavy. So you should have this program on Canvas. You can test it. The thing that I like about this one is it does a between, so it does an and so it's a good reference for that. Does this make sense to everybody? You guys okay with that? All right. Now we're gonna do a calories one. Just trying to give you a variety of different examples with different conditions, so you can take a look and use them as examples. So again, this is on Canvas as well. So this one, we are going to ask them a couple questions. So how many calories are in the food? How many fat grams are in the food? Then we're going to multiply the fat grams times 9. And if the total calories is less than 0, or the fat grams is less than 0, then we're going to say that they can't be less than 0. They can't be a negative number. But if the fat grams is greater than the total calories, so we'll say else if the fat grams is greater than the total calories, then we'll say that's invalid because you can't have more fat grams than you have calories. Okay, but otherwise, we're going to go ahead and calculate. If we take the fat calories divided by the total calories, what would that equal? Multiply it times 100 to get actual, instead of getting the decimal number, we'll get the decimal, but we'll get a percentage number. That instead of saying like 0.78, we'll get like 78. And if it happens to have more numbers, it'll also have the decimal. Okay, and then once we figure out what that is, then we're going to see that if the food is low in fat or high in fat. Okay, does that make sense to everybody? Okay, so let's try it. So first of all, I'll enter some negative numbers and see if my invalid's working. So you should have this on Canvas so you can play around with it too. So if I have negative numbers here, then it'll say that can't be less than 0. Okay, now let's put in how many calories we have. Let's put 90, but let's put that we have 100 fat grams. And it says that you can't have more grams of fat than you have calories. So that was the other option. So that was the option here. So the first problem was, are there negative numbers? So this handles negatives. I like this example because it uses an or. Remember that the or handles invalid options if you start with it at the top. And so with invalid, if you're less than 0, or if either one of these is less than 0. So if this one's less than 0 or this one's less than 0, then we have a problem. Okay, if either of them are less than 0. Now, this one is what I just did. So if the fat calories are more than the total calories, then that's a problem as well, because that can't happen either. And so this has curly braces because it has more than one cout statement. This one didn't have curly braces because it only had one cout statement. So you need to have it here. You can have it on this if you want to just stay consistent. But with your if or your else if doesn't have more than one, then you don't need to have the curly braces. And this one definitely has it because it has a bunch of things in there. And so if it's not invalid with either of these two, like the fat grams aren't higher than the total calories, or you don't have a negative number, then it's going to do the calculations. It's going to match the else. And this is where it does the calculation. So I haven't gotten that far yet because I haven't put in a number that's valid. So let me switch those two numbers. So if I put 190, that's a lot of fat. Okay. How many fat grams? Okay. Let's do something smaller because I don't think that's possible to have that much fat in the. So we have 500 calories and we'll say 10. Okay. So 18%. And so let's try something a little higher. It says it's not low in fat because it's 54%. Okay, does that make sense to everybody? I like that one because it has the or up here to look at for the validation. And then the last one I want to show you before we talk about switch is this runner one that you have. Okay, so the runner one is determining who came in first place. And so it does ask you the names of the runners. And so it asks you to enter the names of the runner 1 and then runner 2 and runner 3. Because sometimes when you're entering names, that has a problem. That's why it has a see and ignore to kind of help with that, with the names. Okay, because you can use first and last name if you want to. And so it is going to do the times of the 3 runners, and then it's going to validate the times. So if any of the times, so this is an or, if any of the times is less than 0, then of course it's going to be invalid because you can't have a negative number of time. Okay, you can have 0, but you can't have negative. Okay, if it's not invalid, then it goes to the else, and we'll say it's valid. And so if it's valid, we're going to go ahead and determine who the first place winner is. So in order to be in first place, your time has to be less than both the other runners. And so if the time 1 that you entered is less than time 2, and time 1 is less than time 3. So you have to not only be less than the one runner, you have to be less than the other runner as well. So with an and, you can make sure you're less than both runners. Then we're going to put the place 1 of runner 1 because they're won first place. And then if time 2 is less than both the other times, then they're in first place. And if it's not runner 1, not runner 2, then the only other option is runner 3. Okay, so this helps determine first place here. And then to determine second place, you have to be less than the one time, but not less than the other. So see how it says time 1 is less than time 2? And time 1 is greater than time 3. Because if it were less than both, they would have been in first place. So it's less than 1, but not the other. Or we'll say that they're greater than time 2 and less than time 3. So these are the 2 options. So basically you beat the one runner, but not the other one. That's what that's saying. And if that's not the case, then did the second runner do that? And if runner 1 didn't do that and runner 2 didn't do that, then it has to be runner 3. So we have to find out who's in second place. And then the third place would be if your time was greater than both runners, then you're in third place. Does everybody understand that logic? So this gives you a bunch of ands to work with and ors, and this one even switches up. There's 2 options here. It may not have been this one where you were faster than the first runner and not faster than the second, or the third, I should say, in this example. But maybe it was the other way around. And so the or handles the other way around. So you're just faster than one of them, right? And it's trying to determine, were you faster than the one or were you faster than the other? Okay, so if you run it, it should determine, you could put in some made up names. And so we can say Bob, and his time was, I don't know if we're going by minutes. We'll say 30 minutes. And the second runner, Joe, his time was 25 minutes. And we'll say Bill, and his time was 23 minutes. Okay, so then in that case, Bill came in first, and Joe came in second, and Bob came in third. So put in some names and some times, and it should rearrange them in the right order, hopefully. And hopefully the logic makes sense, but it may take some time to look at it. But it is quite an involved program. Just make sure that you have plenty of examples to work from with different scenarios. Does everybody understand the scenario and the logic of it? Okay, what I want to do next is talk about switch statements. So hopefully you understand conditionals with if else pretty well. You know, when do we have just an if by itself? When do we have an else if added for other options? And then the else at the end is the default. Now, you also have to decide if you have complex conditionals, like if you have or and when to use them, like and is between and or is opposites. And so it just depends on what you're talking about, how you'll do it. Sometimes you'll put if statements inside of each other, but usually when you do that, you can also just add an and. Like if you're doing an if inside an if, you can just make a condition that has an and with it that includes both criteria. But sometimes you don't want to do that because sometimes you might want to separate with the cases between if this happened and if this didn't happen. So a nested if makes sense. It just depends on what you're doing and how you want it to print out. Okay. So what I want to do is I want to show you the slides that we didn't go over yet for switch statement. And then I'll show you some examples with switch. Okay. So a switch, you just actually write the word switch all lowercase, and then you have to have some sort of variable that you're comparing. And it has to be the same variable you're comparing throughout. So the variable has to be the same. And you put that variable in parentheses. And then you always have a curly brace here and a curly brace here to end. That is your entire switch. And basically what you normally use it for is if you want to know that with the book club, it would be a great example because we know if we read 0 books, this is what it was. And if we read one book, it was this. And if we read 2 books, it was this, and 3 books. And so what you do is you put case. And so if case 1 colon, and what do you want to do if that's true? Case 2 colon, what do you want to do if that's true? Case 3 colon, what do you want to do if that's true? Now, the same thing like if you do if, else if, and you put an else at the end, you don't always have to put the else, right? The else is like your default. So in the switch, you have something called a default. That is your else, and you could put it if you want to. If you want something to happen if none of the other ones matched, and then you put a default, and if you don't have it, then it won't do it automatically. Okay, so for this example, it's kind of hard to read up here, but if you see it on your slides, you enter an A, B, or C, and it takes in your choice. And so the switch has the variable name choice here. And then if the case is A, so because we're using letters that has single quotes around it, so if case is A, it's going to print out you earned an A. If the case is B, you earned a B. If you C, you earned a C. And default would be you did not enter an A, B, or C. Okay, so that would be like your invalid. Now, one thing I want to talk to you about is you'll see after each statement with each case, there's something called a break. Okay, so just before I talk about the break, does it make sense so far? Pretty easy to understand the logic of it. So you have the curly braces with the start of the switch and the end, and each one has a case of what it should match, and then it matches that one. It does whatever statement or statements, you can have more than one statement, are in there before it moves to the next case. Okay, but a break on a switch tells it whether it should break out of the switch or not. And so if you want a switch to do that one case and be done, then you put a break after each case. Okay. If you wanted to go on to other cases to see if it matches them, actually not even to see if it matches them, it'll go on and match them. And then you don't put a break. And you might say, well, like, why would I want it to go on to cases? Like if the case matches an A, why would I go on to look at B and C? Because I'm going to do them automatically. Like it's going to match them. Let me see if I have an example here. Here, this one's a good example. So if you enter, like you're talking about TV models, okay? And so each TV model you buy has more specifications, it has more features, right? So when you buy the highest model, you don't lose like those basic features that you had in the basic ones, right? So when you have a switch, if you enter 100, 200, or 300, if you get the 300 model, so it does the model number, you get the 300 model, you get the highest quality picture-in-picture, right? But there's no break. So you also get the stereo sound and the remote control. And then you might say, if I entered 300 though, how did it go to the 200 and the 100? Because it doesn't match those. It doesn't need to. If you don't have a break, it automatically matches them. So when you get, if you do 300, it automatically matches everything till it hits a break. So it doesn't matter. But there's a break after the 100. The reason why there's a break is because the default says you can only choose 100, 200, 300. So if you don't put that break on the 100, it'll say you can only choose, like it'll also match the default, even though it doesn't actually, like because it matched the previous one, it goes till it hits a break. And so if you wanted to break there and not go to the default, you have to put the break there to tell it to stop. Yeah. Yeah, exactly. So it makes sense for like models because like as you step your way up and you're paying more money, you don't want to lose the features that you got with the basic things. So like if you pay for the 200 one, you get the stereo sound and the remote control, right? But if you don't pay for, if you get the cheap one, the 100, you only get the remote control, you don't get. So it doesn't go up, but it goes down until it hits a break. And the purpose of that break after the 100 again is so it doesn't hit the default and say it's like invalid. Because if you don't put the break after the 100, then it'll get to default as well. So if you wanted to include default, then you would take that break off, but it doesn't make sense in this particular case for it to hit the default. So yeah, it just ends, no, so end line, like, it's just for printout, like just get like an enter basically. But the break actually is used for loops as well. We haven't talked about loops, but the break breaks out of whatever structure you're in. So like in this case, a switch, it tells it to go out of the switch. So like if in like a loop, if you're in a loop and you want to break at a certain point, you put break and it breaks out of the loop. But like for the switch, the break breaks out of the switch. And so, and it sounds kind of silly, like why do I need a break? Because I don't, but in this case, like if you do want to include all the other things underneath, then it actually works really nice. And so I always tell students, I like the example, and here's the output, what it looks like. If you pick 100, you only get the remote. And if you pick 200, you get both. And if you pick 300, you get 3. And if you enter something invalid, then it says that you're not valid. Let me see before I talk about something. I don't know if I have it on here. So switch statement is used for menus. It's great for menus. Like if you're doing like, what model do you want to buy? And then it prints off the options in that case, or you could tell the user to enter this if they want to do this. We did a program together, which is the different levels. You can get an adult membership, a child membership, or a senior membership, and you could pick from a menu which membership you want, and then it could do the calculations and print out how much it costs. We're going to do that as a switch and see what it looks like because it's a little easier with the switch to do menus than it is with like the if else. Now, I will say the switch is more limited than the if else. You can't do everything that you can do with the if else structure with the switch, but sometimes the switch looks nicer for menus and things like that. So the if else works for everything. It's more versatile, but the switch sometimes makes makes the code more readable, makes it a little easier to understand. So does that kind of make sense to everybody? Think, okay. So that was the end of the switch. So I want to talk about something, and then I'm going to give you some examples in the next class about that. So with the break thing, trying to envision it, usually this makes sense to everybody. So if you were doing a program where you're having them figure out, if they won first, second, or third, or maybe they just get like a participation trophy. Okay. So if you're thinking about that, you want to have the break in that case because if you come in first place, you shouldn't get the trophy for second, third, and participation. That's a lot of extra money that they're spending giving you all 3 trophies. Normally you don't get all 3 trophies, you just get one, right? So in that case, you'd want to put a break because if you win the first place trophy, that doesn't mean you get everything underneath. Okay, and if you win second, that doesn't mean you get third in participation. They probably want to see those for, not giving out multiple trophies for each person would be expensive. And so normally you just get the trophy that you have. And so break for that program would make sense. But if we're talking about like models of things, like models of cars or models of TV, it makes sense that if you buy a higher car model, then you get all the things with it. Like, I mean, you don't lose cruise control because you bought the higher model because it doesn't make sense. So what are the basic features that a car comes with? Those will be at the bottom. And then as you step up the ladder and you get the top feature, you should get everything under it. And so you wouldn't have a break because you want to include those things. And so just because it doesn't match that particular model, it's still, if you don't have a break, it's still going to go on to get those included if you don't put the break. So it just depends on what type of scenario you're talking about, whether it makes sense to have a break or not have a break. Okay. Some other things that we might run into that I wanted to talk about as you're coding. So if you look at this, the income is the condition is described here. Income is greater than or equal to the minimum income. And so here you're declaring a variable inside of this if statement. See how this from here to here is the if statement. Like that's considered a block of code. And this variable int years, anytime you see what data type of variable is called variable declaration, anytime you declare a variable inside a block of code, it's only good inside that block of code. And so that may be what you want. That's maybe all you need it for. Maybe you don't need it later in your program. But if you need that years variable later in your program, you're not going to be able to use it. Now, if you define it in a block of code and you have an inner block of code inside that block of code, it's good inside there. So like if you have an outer block of code, inner blocks of code can use that. But anything outside that block of code cannot. And so in here, I'm using the years, like I'm asking for the years here, and I'm using it to determine this, to print out this, so it's probably fine, it's okay. But if later in my program, outside of that giant if statement I have, I want to use that years variable, it will tell me it doesn't know what it is because it's outside of scope. Okay, so outside of scope means you declared it in there, so you can only use it in there. Okay, so what if you want to use it later? How do you do that? All you have to do is take this variable declaration, line 21, and move it up above your if right here. If you move it outside of the block of code that you're in, then it's good for the whole thing, okay? But if you define something in a little block of code, it's only good in there. It's called scope. It matters where you declare it. That tells it where it's good for. So if it's in a, just think like, if you declare a variable inside a set of curly braces, it's only good inside those curly braces and anything inside that curly brace. Does that make sense to everybody? So just be careful of that, because if you ever have that and you try to print years later and you're like, I have it right there. It's like, oh, but it's inside the curly braces there, so it's stuck there. So, okay. And the same problem you might have, or maybe it's not a problem, maybe you want it to work this way, is that you might have, here is my main function, and here I have this variable called number, and I'm asking them to enter a number. Okay, so it's going to go in there. It's going to determine if number is greater than 0. But then inside of this if statement, I have another variable called number. Okay, you're probably saying like, why does it even let me do that? Because I'm declaring number twice. You are actually having two separate number variables in memory, because one is the outer scope in the main function, and one is the inner scope. So when you're in that inner scope, this one here, this if statement here, the number that you're referring to is going to be this one here, the one in the inner. When you come out, it's going to be the number in the outer scope. So how does it know which one you're talking about? If you're in the curly braces that it was declared in, it'll be that one. And if you're in inner curly braces inside those curly braces, it'll be that one. And when you come out of that one, it'll be the other one. So typically we try not to give things the same name because that's confusing, right? So you can see that inside this if statement, the number is the one in here, this one. But when we come back out, it's the first number. So it's kind of tricky. So just be careful. And why does it let you do that? Because they're separate. Like when you're in separate curly braces, you can have that same name because now it's a separate place in memory, even though it has the same name. But then when you come out, then you're referring back to the other one. So again, trying to give them different names probably makes it you'd be able to keep track of them a little easier. Okay. Let's see. So does that make sense, everybody? We're kind of getting that. Okay, I have some examples for you with switch statements, and I believe I have them on Canvas for you in a folder called switch. And so if you want to take a look at those, we'll start with a basic one. I didn't want you to have to type all this, so I just wanted to show it to you. We're getting more and more typing. So sometimes we can start from scratch, and sometimes just taking a look at it is nice because it's a lot of typing. So this one is a basic Roman numeral converter. And so all it does is ask you for a number between 1 and 10. And you enter a number, it goes into a variable called number. And then it's going to use the switch. So remember the switch, you have to have the variable that you're working with in the parentheses there. So I'm working with number, the one you enter. And if that is a 1, so case 1, then we're going to print out this Roman numeral. And then we're going to break. And why are we breaking? Well, because we don't want to match more, than just the 1. Like we don't want to go on and also print number 2 and also print number 3 and also print, because if you don't have a break, it goes on to do all the rest of them, whether, it's not going to match them because it already matched 1, but it's going to do all the rest anyways. And so we need to have the break because otherwise it goes and matches all the rest. And that's not what we were looking at. So if you enter a 2, you enter a 3, you enter a 4, 5, because they're all separate and they all have separate Roman numerals, we're going to do them as separate. I know it's a lot of work to type them all in, but they're all separate. So unfortunately, we have to put them all in there. Now you could have probably put like the Roman numeral version of and printed that first. So you could just print the actual Roman numeral conversion instead of reprinting the sentence each time. but it's not that big a deal, I guess. And then this one is the default is going to say you didn't enter a number between 1 to 10. Now, it's not a loop, so it's not going to ask you again. You would have to run your program again for it to ask you again. It's just going to print that didn't work, basically, that you didn't enter a number in range. And so testing, if you enter a number out of range, like 11, it's going to tell you have to enter a number and you're going to have to run it again. So it's not going to run again. But if I enter a number in range, hopefully it gives me the correct Roman numeral for that number. So test your different Roman numerals and see if it's working. And all it's doing is matching. And remember, each time it matches one, the break needs to kick it out of the switch so it doesn't match any of the other ones after it. Because if you don't have the break, it automatically matches everything after it until it hits a break. And so in this case, it doesn't make sense for it to do that. And so we are going to kick it out and just print the right. Did you all see this one? Does this one make sense? So usually switch isn't too bad to understand, hopefully. Maybe even sometimes a little easier than the if-else structure. But you could do this program as a if-else. All you would have to do is instead of putting a switch, you would just put number equal 1. So if number equal 1, just like we did with the book one, else if number equal 2, else if number equal 3. And there's nothing wrong with that. That's fine. I mean, there's no right or wrong. If you don't want to do the switch, you could do the if else if. You don't have to do the switch. But sometimes this one looks more like a menu and it makes sense to people to like, okay, this one and this one. With the if else if structure, you don't put breaks on it. Like if it only is going to match one, and once it's done, it's going to pop out. But with this one, we have to determine break or no break. And that's one cool feature of the switch is that you can go on to match all of the ones after until you hit a break. And so it's kind of nice for all those different models and things that we were talking about. Okay, so what else do we have? Okay, this health membership line, I'm going to show you this one. This one we looked at the other day. Okay, so this one was the one where we asked them how many months. And so we have the different constants at the top that give the price. And again, you don't have to. Throughout your program, you could have just used 40, 20, and 30 in your equations instead of putting the variables up here. But it's kind of nice because you just have one place to change them. You don't have to go through your program and remember what equations to put them into. So this is going to print your options. You can enter 1 for adult, 2 for child, 3 for senior, or 4 if you want to quit. Okay. Now here, this is just used for printout purposes to make you have 2 decimal places whenever you print the answer for the cost. The switch is going to take the choice you entered up here, and it's going to determine, okay, if you entered a 1, here's what's going to happen. Now, I like this example because it has more than one thing you're doing in here. And so with the switch, you don't have to just have one printout statement. You can have multiple things, like you can have calculations. And so it is asking you how many months and then multiplying it and printing it. And we talked about this before. You can restructure this program whatever you want. You can take how many months and put it before. But if you do that, then you have to make sure it's the choice is between 1 to 3, because if they enter 4, it doesn't make sense to ask them how many months after they told you that they want to quit the program. And so that's the only problem with pulling that out, because you can see you're repeating it and you may not like repeating it like that. But if you pull it out, then you will have to add a condition that makes sure that it is between choice 1 and 3 before you print that. Okay, so you can see you can ask how many months and then you multiply and then you print off. And this up here, instead of repeating this, you just put it once up here, then you can get that format for the cost for everything. And so if you don't enter 1, because it's going to break, so you're just going to pick 1 membership. And so it makes sense that once you match that 1 membership, you're done. You don't go on to match the rest of the memberships and print those as well. And so the break is important here. And then if you don't enter 1, it will see if you entered a 2. If you entered a 2, it will do this one. And if you did enter a 2, it's going to break. So it's not going to go on to match the 3. And then if you didn't enter 1 or a 2, then is it a 3? And then it's going to break if it is a 3. And then 4 is when you want to quit. So it's just going to say quit and break. And then the only other option is you didn't enter a choice 1 through 4. Okay, so we'll go ahead and run it and test it and see if it works. If we enter adult membership, 3 months. What if I want to quit right away? It says we're quitting. What if I don't enter something that's an actual valid option? Well, that's not good either. Child membership for 9. Just testing different options. What if I get senior for 13? Okay. All right. Does that work? I want to pull up the other health membership that we had before. Okay, so we can compare the two. This was the one we had before, and it still had the constants at the top. It still had the same menu. We did pull this out and then we added a condition later. But if you wanted to put this back in, just like so it matches the one we have, you would put it in here. So each one of these would look the same as what you have as the options for the other one. And so if you're doing an if, else if for this instead of the switch, you would need to have the curly braces because you have more than one thing that you're working with, more than one statement. And so you have multiple. So you do need to have the curly braces for each of these. And then you would just put equal to 2 equals if you're checking. So choice equal 3, for example. And choice equal 4. And then else. And so they're all connected. So in this case, they'd all be connected. So we'd start with an if, we do else if for all the different options, except the last one we can make an else because that's the invalid option. And this would be completely fine. So if you like this one, you want to stick with it, that's fine. Or we can do the switch. The switch, again, usually, keeps it a little neater, I think. You don't need the curly braces all throughout and everything. And so really it's up to you. For this one, you could use either and they both work. So it would really just be a preference thing. Do y'all see the difference between the two? The two programs? So hopefully you have both of those. They should be on Canvas so you can use them. Anybody have any questions so far? It's okay. Okay. Let's do the days of the month. So the days of the month is another switch one that we have. And so what we're doing is basically we are asking them for a month, 1 through 12. We're taking that month and saving it in month. Okay. And then we're asking them for the year. The reason for the year is to figure out if it's February has different number of days. So February is a problem. So the year helps determine if it's a leap year or not. And so the switch is going to take in the month. Okay. And so if the month is 1, that's January, then we're going to just say that January has 31 days and break. Now, why didn't I have to put 31 days? Because the default up here for days is 31. And so if you set your variable at 31, then you don't need to keep saying days equals 31 because it's already 31. So we would only change it in the case that it was 30 or 29 or 28 in the case of February. So you could, and if you didn't set it to 31 up here, you could put here days equals 31, right? But because it's already 31, we don't need to put that. Does that make sense, everybody? If it's already set to 31 as the default, then we don't need to put days equals 31 here. Okay. What if it's February? This one causes a problem. So February, we're going to determine how many days it has based on if it's a leap year or not. So basically based on your year, this works somehow. If you modulus it by 100 and get 0, 400 and get 0, or 4 and get 0, then it has 29 days. Otherwise, it has 28 days. And the rest are a lot easier. So this would be March. It has 31, so we don't need to do anything. April has 30. So see in April, we do set the days to 30 because we initialized it with 31. So because it was 31 before, we do have to change it to 30. So at the top, it was 31. So if it's April, we're going to change it to 30. May has 31, so we're not doing anything. June has 30, so we have to set it at 30. Each one of these has a break because we don't want it to go on to set the days for each of the other ones because then it won't just do the month that we're doing. It'll do all the months after it, and that's not good. So July has 31, so we don't need to do anything. Same with August. 30 has, September has 30, so we set it 30. October has 31, so we don't do anything. November, we set it 30. And December has 31, so we don't do anything. So again, you could have put days equals 31 through all of these, but to save on having to do that, just because it's set at 31 up here, we don't need to. So whatever default you pick, we picked 31 because more months have 31 than have 30. But you could have went with 30, but it would just be more setting it at 31. Okay, and then it's going to print the number of days. So let's test it and see. If we enter January and we enter, it doesn't really matter what year for January, but we can enter this year. Actually, 2025 now. It doesn't matter. It's still going to say 20, the same number of days. It's February that makes the difference. So let's try March of this year. 31 days. Doesn't matter again because the number of days for the months are all the same except for February. The only reason for the year is to see if it's a leap year or not for February. So let's see. Okay, is this a leap year? So let's do February 2026. February 2027. There we go. February 2028 will be a 29 days. Okay. Well, you can figure out every 4 years is a leap year. Okay. So that's why you do the modulus 4, because every 4 years would be a leap year. So you can figure out February. All the rest of them should be, doesn't matter the year, it should be the same number of days in the month, but February every 4 years would be 29 days, otherwise 28. Does that make sense, everybody? Oh, okay. So you can play around with that program and see if it's working. We're gonna go ahead and stop here because we're getting close to the time.